Hello, welcome to Bradley's Maths. This is video 1.3a, the first of three videos aimed at worksheet 1.3, prime numbers, highest common factor and lowest common multiple in the number for GCSE mathematics range. The worksheet is available on my website. So let's get straight into this with what is a prime number? A prime number is a natural number with just two factors. The factors are 1 and the number itself. So let's reveal that there. A prime number is a natural number that has just two factors, 1 and itself. And that's all there is. That is the definition of prime numbers. What does it mean? It means there are no negative prime numbers. It means there are no fractional prime numbers, just natural numbers, the counting numbers. Do you remember those? Okay, is 1 a prime number? How many factors does 1 have? It's 1 times 1, I guess. So 1 has only one factor. And yet, as it says here, we need to have two factors, just two factors, not just one factor, just two factors. And we only have one, so 1 is not a prime number. Are there any even prime numbers? Well, let me tell you that yes, there are, but there aren't many of them. There is one prime number that is even. That one is the number 2. And it's the only even prime number because 2 is a factor of every other even number. 2 has two factors. One of them is 1 and the other is 2, which is the number itself. So 2 is the only even prime number. Okay, we're going to find some prime numbers now. You may well have seen this before. This is called the Sieve of Eratosthenes. I hate this guy's name. Honestly, I really do. I always want to put an S in where the first T is. It's Eratosthenes, and he was an ancient Greek, and the algorithm for finding prime numbers has been attributed to him for whatever reason. Maybe he really did find it. So what we're going to do is we're going to follow the algorithm exactly, and we are going to find some prime numbers. Let's have a look what we can find. So follow the instructions to find all the prime numbers between 1 and 100. Okay, fair enough. Cross out 1. Instruction 1, cross out 1. Well, what I'm actually going to do is I'm going to erase 1 completely. That's 1 gone. Let's go back to our list. Leave 2, but cross out all its multiples. Now this time that's an awful lot of crossing out to do, so I'm not going to cross them out. What I'm going to do is I am going to highlight them. I think, let me see if I can do it that big. Yes, I can. I'm going to highlight them, and all the multiples of 2 are the even numbers in here, and I'm just going to highlight them all in this table, just like this. Notice that 2 is not highlighted because it says leave 2. 4, 14, 24, 34, 44, 54, 64, 74, 84, 94, all even numbers. The same with the 6s, all even numbers. There they go. The same with the 8s. Oops, And the same with the tens. There they are, all gone. Right. So leave two, but cross out all its multiples. Do you know why we're leaving two? Have a think about it. I've actually already told you why. So leave three, but cross out all its multiples. Okay, let's cross these out in red. Okay, the multiples of three. There's six, but I don't need to do any that are already colored yellow, so I'm not going to do any more of those. 13, 15, 21, 27, 33, 39, 45, 51, yes, three 17s, 53, 55, 57, three 19s, 63, three 21s, 69, three 23s, 75, three 25s, 81. 81 is 9 squared, but it's 3 to the power 4. Okay, and it is a multiple of 3. 83, 85, 87, no. 89, no. 91, 85, is that? No, it's not. 93, yes, 93 is, and 99 is. That's all of those. Let's change our color, not to blue because our numbers are written in blue. Let's go to this green. Okay, and we'll reveal the next one. Can you guess what it's going to say? It's going to say leave five, but cross out all its multiples. So this one's already crossed out. When I say this one, I know you can't see what I was pointing at there. But what I was pointing out was 15 is already crossed out. So I've got 25 and 35 to go, 55 and 65 to go, 85 and 95 to go. All the numbers ending in zero have already gone. So that's the fives. And then in this wonderful, looks like a sort of a brownie color, I am going to leave seven, but cross out all the multiples of seven. So let's see what we've got here. Any multiples of seven? We're leaving seven. 14's already gone. 21's already gone. 28's already gone. 35 is gone. 42 has gone. 49, there he is. 49 is gone. 49. 56, that's gone. 63 is gone. 70 is gone. 77, there is 77. 79, 83, 87, 89. I've missed one, definitely. It's not one of the sevens. 87 is a multiple of 3. What color did I use for 3? I think I used red. I managed to miss the 87 there. Don't know how I did that. But there we are. The numbers that are not highlighted in any color are all the prime numbers in between 1 and 100. And it says write down all the numbers that remain. So let's go back to our blue color. Oh, no, it's not. Yes, it is. Yeah. Our blue color with the pen. Okay. Our numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. I think that's probably far enough down the page. Let's go back up here. 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 91, and 97. Why did my one not come out there? Let me just put that one back in. Doesn't want to come in. Let me just do a quick erase on that and see if I can make it work better. 91. There we go. And 97. So that is all the prime numbers between 1 and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, 19, 20, 21, 22, 23, 24, 25, 26 of them. You don't have to learn them. You do have to know how to find them. Remember, they all have one thing in common. They have only two factors. One of the factors is 1, and the other factor is the number itself. All of them. I've seen questions that go along the lines of, Jack says that any number ending in 1 is a prime number. Is he correct? And the way of looking at that is say, well, 21 is a composite number, 51 is a composite number, 81 is a composite number, because 21 is 3 times 7, 51 is 3 times 17, and 81 is 9 times 9. You only need one example to prove Jack wrong if you get a question like that. And it's the kind of question that can come up on an exam paper. Let's jump on and see where we're going next. Prime factorisation. Every number greater than 1 is either a prime number or it can be expressed as a unique product of prime factors. This expression is, or this process of getting the unique product of prime factors is called prime factorisation. And the easiest way to do it is by creating a factor tree. And the example is express 60 as a product of primes. So I am going to show you how to do that. Let's do that in, well, we're in green, aren't we? So let's do it in green. I start at the top of the tree with 60. As you can see, it's not quite the same green, but it doesn't matter. And what I do, this is the way I do it, and it's not the only way to do it, but this is the way I do it. I take the lowest prime number. The lowest prime number is 2. 2 does go into 60, and I draw branches, 2 and 30. This left-hand branch here, is now finished because 2 is a prime number, so that can't be subdivided any further. Okay, back to the pen. 2 goes into 30 because 30 is an even number. 2, and it goes into 30 15 times. 15 is not divisible by 2. The lowest prime number that divides into 15 is 3, and it goes 5 times. 3 is a prime number, 5 is a prime number. The bottom of every branch is a prime number, and 60 equals 2 times 2 times 3 times 5, which in turn equals 2 squared times 3 times 5. Okay, there is no different prime factorization for 60. It says up here somewhere, yes, there it is, there's the word, expressed as a unique product of prime factors. And this is what it means. 2 squared times 3 times 5 equals 60. 60 equals 2 squared times 3 times 5. Nothing else, no other prime factorization can come up to 60. Okay? Now, there's more than one way of finding this. So let's find an alternative. Let's do the alternative in yellow. You still have to, it's still best to do a factor tree. But 60, you might not have come up with 2 and 30. Maybe you came up with 4 and 15. Well, fair enough. You came up with 4 and 15. 4 is 2 times 2. And 15 is 3 times 5. And 60 equals 2 times 2 times 3 times 5, which equals 2 squared times 3 times 5. And that is all there is to it. It's very simple to come up with a factor tree for any number, really. Even quite big numbers, you can factorize fairly quickly if you do it whichever way suits you the best, because I'm not going to be sat in your exam. You're going to be sat in the exam. It's you that's going to have to do this. You do it the way that suits you best. It doesn't matter which, but you stop doing it when you have a prime number on the bottom of every branch. That means you've finished. That's it for this video. HCF and LCM, highest common factor, lowest common multiple, are in 1.3b, which is the next video in this series, and some sample questions are in 1.3c if you'd like to have a go at either of those videos. They both relate to worksheet 1.3, prime numbers, highest common factor and lowest common multiples in the number for GCSE mathematics range, and the worksheet is available on my Bradley's Maths website. Thank you very much for listening. Please take the time to like, subscribe and leave a comment. Bye.